Alors, peut-être je commence avec une histoire. Sorry, I will speak English as I promised. Actually, last night I did. Despite the title, you're not going to talk French. No, of course. So maybe to start, let me informally tell you a story which is quite a while ago. I mean, I'm actually still departing, finishing my semester sort of. So memories of the semesters maybe you can ask later on. But let me go back to 1990, 33 years ago, when I came back from California, I'd done my thesis, and I became chairholders in the CNRS. And in those days, I was in Besançon, in Jura, which was very francophone. And the first meeting we went to was Cirm. So we left at 7 in the morning from Besançon by car with people from Saint-Fleckengé. And there was this tunnel on the way in Lyon, so you really had to leave early, right, to be in time. So before noon, we were already here in Marseille, but wait 5 hours until things opened. And there was this great center. And well, we went to the Calanque, I think, just to wait for the opening, and I said, wow, that's a great place. And then I was a nouveau au CNRS, and I was supposed to give a talk, right? And so I did, but I was employed by the French state. People told me, you're now employed by the French state, so you may as well speak French. And I was a little bit surprised, being from Holland, we sort of neglect our local language, and we pretend it doesn't exist. So whenever we have an audience like this, all Dutch, and one foreigner opens the door and looks around the corner, we immediately switch to English. And here at Cirm, things were a bit different, and I thought there were many Americans and English, and even Germans. I said, okay, obviously it's going to be English. Mais non, ici on parle français. So, and people know my obedient character, so that's what I did. I did speak French all the time. Of course, I also like protesting a little bit, so I wrote in English while speaking French. That very much reminded me of your act, but in those days I was just on my own. It was lots of suffering. Since it's always best to speak your local native language, right? Being Dutch, that's not always possible, I realize, so I have to live with that. Anyway, so the topic actually is, we started talking about pictures and YouTube and that kind of thing. People who actually want to hear about my semester, which is arithmetic statistics, are going to be disappointed. But only a few months ago, I did give a talk on what is arithmetic statistics, which is on YouTube now, the Cirm website. So if you really want to know what the semester was about, please look at that one. Today, we're going to do something completely different. It's about Escher à la marseillaise. And what does that mean? I assume, the takeaway message. That's what I learned from the previous speaker. What is the takeaway? In case you're going to fall asleep at the end of the afternoon, this is what you're supposed to take. Mathematics and art, which is something that also very much is encouraged also by the current Jean Morlet. That's pretty broad, right? And there's many facets. And today the math is there to discover the structure and to describe it. So it's the use of math in art, if you want. And I also want to show that it's really applied in the sense that once you understand how things work, you can actually use that in real life. And the example that I will be using is a lithography by Escher, and I'm assuming that you actually know who Escher is. Here he is. He's a countryman of mine. He's Dutch, graphic artist who died slightly over 50 years ago, and many people know him for his works of art that are considered to be rather mathematical. So before focusing on the one picture I will try and analyze, let me just flash a few of his well-known work. Oh, just one at a time. People who like tilings, Escher also liked tilings, but his tiles typically were animals, birds in this case. This is a picture that he created when he went back to Holland. He spent lots of time in Rome, 15 years. In the 30s he came back to Holland, which is a flat country, as people know, and it's all naturally tessellated by meadows. And you see all the themes he liked. There's black and white, there's the symmetry, the tessellation, the gradual transformation. These are things that Escher liked quite a bit. Somehow, if I push it once, it does it twice. Variations on the theme, the tessellation is still there, the tiling. Whether it's beautiful, that's a matter of discussion, but at least it's sort of the tension between 2 and 3-dimensional is pretty visible. This is called Encounter, I think. Another one, flat 2 and 3D. See the lizards that are, there's the tiling, the hexagonal tiling, and they actually sort of detach themselves, they creep out, and it's circular, the thing goes back into itself. Later in his life, there was the International Congress of Mathematics in Amsterdam in 1954, which was coupled by an exhibition of Escher. So mathematicians got to know Escher, and conversely, Escher also was told about mathematics. and his tilings used to be sort of the classical tilings of the plane. Here you see an example of hyperbolic tiling. And of course, that's something that he learned from the mathematician. But his tiles, well, devils and angels are typical Escher. Another one that people like very much is this playing with perspective. This is a famous example. If you sort of look at it at first sight, nothing seems to be wrong. The building is not exactly Dutch. You see that it's been in Italy quite a bit. But if you stare at it a little bit longer, you somehow realize that these monks that are walking the stairs on top, they're going in circles, right? But if you look carefully, you may want to decide whether you're walking up or down. I think the title of the name of the picture is Up and Down. They walk up and down, and still they go around. And if you don't think for a second, what is up and down in this picture? And that is not so easy to decide. And if you don't get what the problem is, let's try and make it even more visible. In the Belvedere, this is the Belvedere of Escher, different from the one we have here at Bimini. And again, if you stare at the picture, you do realize that there is a slight problem with perspective, right? For instance, this lady, for instance, is sort of looking this direction, and the guy below her is looking in another direction, but still they're in the same part of the building, so that doesn't work. And the ladder, is it inside or outside? If you look here, it's outside. If it's here, it's inside. Still, it's in the building, so it doesn't fit. And, well, the solution is at the bottom. If you see there's a cube, and if you sort of make things cross the wrong way, then you get funny pictures that Escher was very fond of, and that people like very much. Another example, less complicated than the previous one. Again, locally, nothing seems to be wrong. However, I will change the picture in two ways. It's animation I actually got from internet. I don't know who actually created it. But if you look at this picture, pretty static. Also look what happens. Here's a woman who's actually taking care of the laundry. Whether that's something that needs to be done on a picture, we don't know, but the lady is gone and the water is flowing. Good. Again, before I start, the last two ones, so you see this 2 and 3D is something you like. Also the self-referential aspect. In many of his pictures, the hands that draw themselves is something that he really likes. And also playing with perspective is one thing. He also tries and deform things in continuous ways. So here you see, again, this typical Italian style set of buildings, and somehow looks like if a sphere of some kind has been pushed in. I guess after this introduction, we're ready for the picture, which is the topic of my talk. And somehow, maybe this I just use the laptop, which may make my life a little bit easier. Right, here's the picture we want to talk about. This is the print gallery. And as you see, it is indeed a gallery which prints. And if you look at it, yeah, you see you enter the print gallery here at the bottom. Your eye is sort of naturally guided to the left. And you see this guy standing and watching print. And the print is a harbor front. The harbor front spans again to the right. And it includes actually a building all the way on the right, which is the print gallery itself. So you see this is again self-referential in the sense that he is actually looking at the picture which contains the building in which he is standing himself. So he is looking at himself, but he's there only once, which is somewhat surprising. And of course you also see that, not exactly the normal way of depicting the world. Things have been deformed a little bit. So the questions I'd like to discuss and answer in my talk are two, and they're not exactly mathematical questions. Let me just point out first that there is a hole in the middle. You must have realized there was a white hole in the middle already before I told you, and it's used in an efficient way. You can see it from May 56. His initials are there. Maurits Cornelis Escher is his full name, the signature, and it is the number 20 out of 47, which is the second print run. There's 3 print runs, I think, since stone is now somewhere in the US. And there was a cross over it to make sure that there will never be a print run. We go with this lithograph. All right, here are the questions to be solved. And they're not exactly mathematical, as you see, but life doesn't come with questions that are immediately mathematical. You need to make them mathematical. We are mathematicians. And how did Escher create this picture? That's not even a mathematical question. You should have asked Escher, but he's been dead now for more than 50 years, so That's maybe not so easy. And why is there a hole? Again, that's not a mathematical question. Of course, there is the artistic answer that, of course, it had to be this way because the artist felt there had to be a hole, which is a satisfactory answer. So I will present you the answer, which is due to Hendrik Lenstra. This is not a very recent picture. I think this is when the whole Escher thing started, 2005, I guess, roughly speaking, taken in Oberwolfach. And Hendrik is someone who thinks very mathematically, 24 hours a day. And he answered that question in a nice way. And out of his answer, many people actually started developing things that I will show you during the talk. So the story in this case is that Hendrik, he used to be in Berkeley in those days. And Berkeley is far from Holland, but being Dutch, he wanted to see Holland every now and then. So he had this long flight, non-stop, but still 11 hours between San Francisco and Schiphol Airport in Amsterdam. And one of these flights, he was actually leafing through one of these airline magazines. And they typically are about Holland, the Holland Herald, I think it's called, if you fly KLM, and they tell you all the nice things about Holland. And one of the nice things about Holland is that we have Escher. We're proud of Escher. So this is typically the kind of picture you get. And being Hendrik, he asked himself these questions that you saw. And yeah, what is the structure? So how do you actually create this phenomenon? And first of all, before giving you Hendrik's answer, let me show you Escher's answer. Sorry, Escher's answer, excuse me. Escher's answer. This is from his sketches. Yeah, it says sketch at the bottom. There's stamp, Escher, and the upper part is called up. And you see that such a stone, if you have to engrave a stone, I don't know how this actually works, but it's not so easy. You start with a sketch. And the basis of the sketch in the case of Escher is a grid. The word rooster that you see is actually pronounced rooster, and it means grid, more like raster, not rooster. And it's obviously used to create the corresponding picture. If you look at them next to each other, you see, let me try and use this complicated thing once more, many of the lines that you see in the grid actually occur also in the picture. So for instance, these parts of the window that you see here are exactly the lines that you find in the grid. So it really follows in many ways the lines in the grid, and the picture has been fitted, essentially on a grid. So from a mathematical point of view, the question is, what is this grid? And in practice, what happened is that Escher also started out with the normal world. Here you see a normal picture of the print gallery. It is drawn on a grid, and what Escher did, this is explained in the book by his friend Bruno Ernst, The Magic Mirror of Escher, 1976. Escher had died already. What Escher did, like an artisan, was actually using the grid, normal grid, which you see here on the left, and the expanding grid that he created. And actually, every square was carefully copied to the square corresponding to it, and there was this expansion going from, at the bottom at least, from right to left. There was a lot of work, and it did create this very nice picture. And as I said, we now want to understand what is happening in this picture. So the general idea is that if you go around clockwise, every time you turn 90 degrees, you see that the squares that you have, they expand, and they become 4 squares. So it's 4 times bigger. And again, 4 times bigger, and this way you go around. So what does that mean? Here's the picture. If you go around, starting at the right lower corner, you go left and up and right and down, you gain a factor 4 every time by expanding, and then you're back, and you've gained a factor 4 times 4, 4 times 4, which is 256. I'm a number theorist, you see. So apparently, when you're back, you have a picture. Yeah, it's still the same picture, right? So it has to be invariant under a factor 256. So the conclusion is if you go around, here's a sort of the artisan's drawing of the same thing. Yeah, there is an underlying picture, and every time you go up, right, you expand by a factor 4, using the grid that Escher drew. And the conclusion is that the print gallery is an example of what we in Holland call the dropte. Of course, there's many ways to say this. In French seems to be mise en abîme, and it means that the picture that you're looking at contains a smaller copy of itself inside. And in this case, the smaller copy is really much smaller in the sense that in the real world, there's a factor 256, which is quite a lot. And the question is, why would you call that Droste effect? And here is the original Droste tin from 1904, and especially for the French audience, I've taken care to make sure it's a French tin. So this is the chocolate from Droste. Droste is the brand name, and it has poudre solubilisée, so it is to get your chocolate. And it has been around for quite a while. I also got my chocolate as a kid. You just add milk to this powder, and you have a hot chocolate. And the feature that gives the name to the effect is that this Droste nurse actually has a tin on the tin which contains a tin set. And that means that here's a slightly more modern version of exactly the same tin, that the picture repeats itself inside. So the question is, there's a nurse that carries a nurse, there's not a nurse here, and you may want to count the number of nurses, right? And in real life, I mean, if you want to print it, I think 4 is sort of usually enough. As a mathematician, you know, there must be an infinite number of nurses, right? And also, if you're a Zeno, like the Greek, you would realize that actually this tin must contain an infinite number of nurses. And that's actually true. If you zoom in, you do realize that the number of nurses is actually infinite, since, yeah, and that's not so easy to achieve, so you should also realize the other way around, that if you have such a picture, the number of nurses it actually takes to carry such a tin is also pretty large. And behind you, there are these giant nurses carrying the whole thing. So it's a very infinite thing on the one hand, but on the other hand, it also feels pretty finite, since my picture is actually periodic, right? So it also feels like this infinite resolution problem that you may have sort of felt that there was a problem if you zoomed in. You shouldn't have been too surprised, since the only thing you need to do is to make sure of use the fact that the whole thing is actually periodic. Okay, then the question is, this piece of art that I showed you doesn't obviously show a Droste picture, right? So it's a theoretical observation that it is invariant or is based on a Droste picture. What if you want to see it? Well, I told you how Escher created his thing, so here there's no obvious repetition of the whole thing. And the way it was created, I just showed you. And in principle, once you know this, you can also go back. So what people did at the beginning of the project, you just take the picture and you do the same thing in the reverse direction. And what you get is something that looks like this. So there you see the guy staring at a picture, and you may want to zoom in a little bit to see what he's staring at. Then you discover that indeed there is a picture, a print gallery, I mean, and in that print gallery there is this picture. And yeah, you see there's this guy actually arriving. And there you are. So this is pretty periodic. On the other hand, there is this white hole in the middle, and we decided that from an artistic point of view it was beautiful because Escher did it, but here it's quite disturbing. It really sort of messes up the Droste picture that underlies the whole thing. Yeah, since this is the white hole in the middle becomes a spiral under this whole transformation. And these corners are just corners of the picture. So the question is, what should there be? And the way here, so this is the original picture I showed. Yeah, maybe in a way, if you want to see this better, you can also go back to the beginning and do it a little bit faster, and you see that you almost get looks like a movie, right? And here is the movie that you were waiting for. Namely, there is the guy standing, and if you want to zoom in my case, I just push a button because many people behind this project created software for doing so. And you see that just like in the case of the Droste nurse, the Droste picture that is behind the Escher piece of art is of exactly the same nature. However, the factor being 256, if you see one guy, the next one is still so tiny that you don't see him at the time. However, under Escher's transformation, he becomes more visible, as we will see in a moment. Namely, where's the Droste repetition if you go to the actual print gallery, not this sort of Droste version that I extracted out of it. Well, if you stare again at the process, you see there is the normal straight world on the left, which is the rectangle, the square grid that everybody uses, and there is the version that was used by Escher on the right, which is a little bit different. If you look at corresponding things, then you see that there's these squares. They also have the squares here, and if something looks like this, yeah, the corresponds pretty clear. That's again a square. But if you enlarge that square, this is just side length 2, you see that already it less of a square? Well, this is also 4 times 5, more like a rectangle. But the corresponding picture here is, well, topologically, if you want, still a rectangle, but not in the strict sense of the word. And if you make it even bigger, something happens. And you see that if you take a big rectangle and you walk around the vanishing point, you would say, then you get something in Escher's picture that actually is no longer topologically like a rectangle. So this point is actually both here and there. So there's a repetition in the sense that these must be the same points. You can just look at the grid, you don't need a picture at all. Here's the Escher grid. If you walk around, this is a square having side 3, you make 5 or 10, does it change? And 20 doesn't change it. You see that this point and that point actually come from exactly the same point in the real world. In other words, you see there's the origin where everything centers around, and there's these 2 vectors, 1 and something that I call gamma, which is much bigger, and it's pointing in a completely different direction. And what that means is that the print gallery itself, also invariant, maybe not exactly in the Droste-like fashion, but in something similar, you have to zoom in while rotating. So you have to rotate the picture and enlarge it, and then it should become periodic, right? In this case, you saw that the scaling factor, the big thing, is 18 times larger. You can just measure it. And if you just go back, the length is 18, and it's, well, not quite 180, it's about 160. And that factor of about 18 makes everything disappear in the white hole in the middle. So actually, Escher doesn't show us what happens because there's a white hole. So even despite all the artistic objections you might have, there's lots of reason to fill in this hole. And also, Escher has been dead for 50 years, so I think it's fine to fill in his hole without asking. But that may be something for lawyers. Anyway, so that means that we have this hole that we actually would like to fill up. And in principle, that should be easy, right? You have to rotate and, in this case, enlarge, make it smaller than if you want, minimize by a factor 18. And if you do that, this is what happens. So you see, you can actually continue the picture all the way to the center, and it gets a little bit messy because you don't see much. However, we have our movie. So in this case, zooming in is a little bit different in the sense that we zoom in while rotating. And then you can simply sit back and relax and watch carefully. And if you see the guy appears again, standing there, looking at the picture, and that picture has a harbor front with a print gallery. In that print gallery approaches, you see there is the guy standing, etc. So here is the Escherized version of the Droste. And where the piece of art, this original one, nothing in between, that's all a matter of taste that I needn't go into. However, this is a math talk, right? The afternoon was called scientific. So far, I've just been showing pictures, so I felt that it would be good to also include a little bit of mathematics to see that, in effect, that's the basis of creating these movies. So what does that mean? So mathematically speaking, we're trying to find the grid with this funny property. And Escher did it as an artist. And you see this is the back of the thing I showed you before. Actually, he messed up in the beginning, and he glued a new piece of paper in the grid. And the backside, he's really struggling to see what should happen in the center, right? And by hand, that's also not too easy. So you can imagine that Escher was a bit struggling to actually find it. And his struggle, as his friend Bruno Ernst from the book that I quoted from, he says, well, with these straight lines, it doesn't work. And intuitively, being an artist, not a mathematician, he found that curved lines were the way to do it. And what he tried to achieve, with these grids, that original small squares should retain their square appearance, which, if you want, is just a way to say that what you're trying to construct is a conformal map. Since what is a conformal map? That's a map that indeed preserves angles, but not distance. So we need a differentiable map that preserves angles and can deform things another way. So here's the map. The left side is the Droste underlying the Escher picture. And as we discovered, that is a picture which is invariant under the scaling by a factor of 256. So if you view the plane as the complex plane, and there's a little hole in the middle, which is star, the multiplicative group, and it needs to be, every pixel on that plane needs to be the same as 256 times that pixel, because it needs to be invariant under that scaling. So what you're trying to find is a piece of art which lives on C star modulo this cyclic subgroup generated by 256. So all the cosets of this subgroup need to have the same pixel color. For Escher, the only thing that changes is that there's no longer a real factor 256, there was this funny gamma. And rotating while enlarging, that means multiplying by a complex number which is not real. And that number gamma, well, that was sort of found empirically by Escher just to make the whole thing work. But if you throw away the whole picture business behind it, you're just staring at conformal map. You want an isomorphism between Riemann surfaces. And then there is theory to tell you what to do. If you're a geometer or a number theorist or whatever, you know about elliptic curves. This is in fact an elliptic curve. And yeah, the C star is the image under the exponential map of C itself. And what you should do is not construct this map directly on this level, but on the covering spaces that you see on top. And there life gets a bit easier, so this alpha actually becomes just a multiplication by a complex number. So that isomorphism is just a linear multiplication. That cannot be anything because this map, the exponential map, has a kernel, right? 2 pi I. And also, since it maps to C star modulo subgroup generated by 256, you know there is another point in the kernel which is the logarithm of 256. So there's a lattice that you have to mod out. So you're looking at C modulo a lattice. And in case people have told you about elliptic curves, elliptic curve. On the other hand, you see the Escher picture is also an elliptic curve, but it's C modulo a different lattice. And yeah, how does that work? Apparently, to make this conformal, the corresponding lattices need to be conformal. And if you stare at the picture, you see what that means, that this triangle has the same form as that one. In other words, the quotient of 2 pi I and log gamma is the same as the quotient of this expression in log 256. So you just have a formula that tells you what gamma is. Here's the formula. You get a theorem. Say, hey, I'm a mathematician, not an artist. Maybe I'm both. Here's my theorem. Namely, you can just compute gamma that has been used or should have been used for the print gallery. Namely, its logarithm, what I said, log gamma over 2 pi I is this expression, log 256 over that. And you can just compute gamma, and well, the 18 was not bad. It should have been 22.5. This liberty, I think, is okay. And the 160 degrees also is very close. So Escher did really well in approximating the conformal grid. Yeah, this is what comes out of our computer program. And this is what Escher sort of devised by his artistic work. So you see that math and art may produce almost the same thing. Just a matter of preference, whether you want to start from the math or start from the art. All right, so, and as I said, you can now compare them. There's going to be discussion. Did we improve the picture or did it get worse? Did it take away the fascinating white hole in the middle? That's all for philosophers. We may leave the drink afterwards. Let me just formulate the conclusion that we reach. Droste pictures, of course not typically Dutch, but they have a definition. Namely, they are invariant under the scaling by a real factor. A small print you're not supposed to read, but if there are actual mathematicians in this audience, and there are quite a bit, typically this talk goes for anybody, but the factor cannot be plus or minus 1, obviously. In the same way, invariant under a complex factor, a true Escher picture has a complex multiplication, which is by a non-real number of absolute value different from 1. So it's not just rotation, really expansion. And the master trick of the artist was Escherizing the given Droste picture. So the conformal equivalence of two pictures of this kind. Okay, now you can also understand how we create our program. How can you create videos where you keep zooming in without losing resolution? That was the problem that we had to solve, and it comes from the periodicity. So that means that, if you look at the math behind it, there is the logarithmic plane and there is the exponential map. What does the exponential map do to a rectangle in the complex plane? If you move in this direction, you expand exponentially, as you see. In the vertical direction, you just rotate. Yeah, that's the argument. That's the way the exponential map works. And then you just put your own information on it, and you see that the problem that you have in the real picture, that the nurse in this way expands, so you need more and more resolution if you move out, on the logarithmic plane is just periodic. Yeah, you see that nurse and that nurse are identical. So you only need a finite amount of information on the left to keep going to the right and expanding. And the logarithmic plane looks like this. So what the program does is actually moving through in various directions. So expanding just means that you take this logarithmic Droste plane full of nurses, and it's indeed infinite, so there's an infinite amount of information, but you can store it in one fundamental tile in this tiling. And of course, there's also this vertical direction also can be used, that can be used to rotate. So that's the way you do it. And what you get, so this is the way to visualize what the program does. As I just said, if you want to zoom in, then you just move to the logarithmic plane from left to right. And if you want to do, yeah, maybe I shouldn't do that to a nurse, but you can just be rotate, right? And that's the vertical direction in the program. All right. Maybe, actually, to show you a little bit of the program, it also Escherizes it on the go. This is an Escherized version of the Droste picture. Here's another one. We'll show a bit more later on. So creating pieces of art is so difficult to have the program and the mathematicians who did the work. Yeah, but you know that the music with the system here is a bit complicated. So next time, you just come back or whatever. Maybe we should just have another 6 months and then we do it with music, right? Okay, we can take care of this maybe someday. All right, and you can also just use it, since if you want to be an artist rather than a mathematician or both, maybe you want to create your own Escher pictures and show them to the public. Of course, as an artist, you have to sell your stuff, you have to adapt it to the local public. And if you give such a talk as I'm giving now, it depends what the public is. And very often you don't know ahead of time which people are going to be in the audience. So this is something you can actually sell to mathematicians, as I just did. There's exponential maps and covering spaces. And even if people are not mathematicians, they still like it because there's all these pictures. Oh, wow, a covering space, that's good. No idea what it is, but it doesn't matter. So for your reputation and your right, so the way you create such a talk, you just have all kinds of pictures lying around. You just put them together in one script. Then you hope, and your talk starts, sorry, that it's actually good for the audience. Well, we can test. So let me point out that there are certain cultural challenges that I try to make clear. First of all, you can claim this to be a Droste picture, and the typical audience will say, oh, that's not Droste. We already had blah so long ago. And that's exactly the same phenomenon. So you cannot actually appropriate this idea as being Dutch. Okay. Maybe you could say that, then my Droste movie is better than what they have, but already that's a sort of an issue. And these days, well, I called it, I think, present-day sensitivities need to be respected in various places. I think that's a good way of phrasing it. Nobody knows what it means, but it sounds like, that's what you should do, definitely. And having a somewhat mixed audience, even though everybody speaks French, we also speak English at the same time. And we may have also Germans and Americans, whatever, Colombia. And they all have their own way of dealing with Escher and Droste. Here's Germany. So typically what I do if I give such a talk, I ask the audience, what's your own Droste picture? And if you're lucky, after the talk, they'll come to you and say, so this was an old lady in Erlangen. She said, we have cheese, camembert, in fact, Roodkäppchen. And they always have this. This is exactly why I felt that this was maybe not the right issue, the right example to show to a mostly French audience. This is exactly when I tested it already before. They do realize that Roodkäppchen is Japon Rouge, the same girl, but everybody claims her. And the camembert, I think, so Roodkäppchen is for everybody, but the camembert is more typically French, I would say. And the typical that I got was camembert in Germany. Are they allowed to do that? and whatever comes out, it cannot be true camembert, so it must be pretty distasteful. Anyway, but on the other hand, you can say if you look at the actual box that they produce, it's really beautiful. So it looks like the standard French cheese is a circular thing, and yeah, it's ideal to create movies since it's a very nice one because it has such a clear border, I think, a circular thing. So in a way, it's even nicer than Escher himself. And if you try and Escherize it like this, what happens is that the circle becomes a spiral. So you can spiral, and this is the Escherized haute caption turning, in this case, clockwise. And if you rather go for the counterclockwise version, that's also fine. Then you do it like this. And again, they can go both ways, but zooming in is typically more fun than zooming out. When you get dizzy after a while, that depends on your stomach and what you've eaten and how long it lasts. Okay, so that was Germany. Motion sickness, yeah. Okay. As I said, it's not ideal. First of all, it's a little bit outdated in the sense that already haute caption realized that it has to be more modern about gen technique. It's still called camembert, though, but it looks even less like something you can sell to a French audience. So much for Chaperon Rouge. She failed the test, so she's not going to be it. Then we go to the US, the Land O'Lakes, which has been around since the 1920s, I think, for at least a century. And all Americans I know knew about the butter that was sold by Land O'Lakes. And this talk has been given also many times by Hendrik Lenstra himself in the US. And this used to be the example. And if you show it like this, it's probably okay. But then if you want to actually Escherize the lady, she gets a little bit distorted. And it may also happen that you speed up the thing a little bit. And then first of all, your audience get dizzy. And there's the question whether you can do this to a Native American woman. And that was what I was supposed to say when I was a student in Berkeley. I think it was the right way. And the problem has been solved recently. During COVID, Land O'Lakes, which I think stands for Minnesota, right? That's where it was originally produced. Even though Minnesota now is called Made in California, but things change over time. And you see that the Native American lady who actually is very popular, she's called Mia, so you can actually look up what she and who draw the pictures and what exactly she's wearing. There's a lot of information. We don't have time for that. But you do see that actually this is going exactly the wrong direction. Rather than completing the white hole in the middle, they created the white hole in the middle. So Land O'Lakes is really going the wrong direction. And actually her removal is something that also took, well, there was COVID, so people talked about other things. But poor Mia actually got removed, and some people didn't like it. And I think her being removed, yeah, was Native American. And where you can, that's a long story that I won't get into. So there's Land O'Lakes no longer has a Native American, it no longer has a Droste effect. So no US. There we go. This was what I got when I gave this talk in Colombia. That looks pretty local, right? With the polvo para hornear, if you speak Spanish, I don't. But then you realize that actually this is baking powder, and Royal is an American company. So we're not dealing in any way with Colombian culture. This is almost colonial, which means that nowadays it's not exactly the kind of example you want to use. You have to maybe decolonize this talk if need be. Even though the picture itself in its Escherized version is still pretty neat, but maybe not. France. In the old days, in France, there was la vache qui rit. There still is la vache qui rit. And I think this laughing cow is still laughing. There may be questions these days whether this cow is actually laughing or she's forced to laugh. And, yeah. She is. Yeah, maybe she is laughing, but then. Yeah. Well, there are issues nowadays. Yeah, that's also true. So it's a very European thing. So I could use it maybe also in Switzerland, right? That's your question. What's the Swiss thing? You can tell me after my talk. And also these days, if you want to sell it, I've seen the struggles that UREST, which is the company here, has with all the various desires that people may have, being vegan or vegetarian or whatever. And I think anything you see here is not vegan and also not vegetarian. Yeah, well, Gruyere, I don't know. I'm not exactly informed. Another thing that, the reason why I cannot do it is that I used this extensively in Paris long ago in Beaubourg. And when you go to Marseille, you cannot use something that you already did in Paris and say, okay, guys, I did it in Paris. Now for you in Marseille, a couple of years later, you're also going to see it. That's not the right attitude. So even though, again, it is a nice one because it is already, it's not a Drost picture, it is Escher. You see that the keys box is the boucle d'oreille, the earring of the cow, but it's not exactly a copy of what you see. And it means you have to trick things a little bit, first to get the form the right way. This doesn't make a big difference, right? And then you realize that what you see, this earring, is indeed the box, but it's turned over 90 degrees. And that means that what you need to do is zoom in while rotating. So this is already an Escher picture in itself. And again, you may want to wonder what it looks like if you Escherize the cow. So sorry for those people that think you cannot mistreat animals. Yeah. It looks a bit like the elephant, right? The Disney thing. So yeah, well, you can do that. And the other way, she's more cow-like, but still she's a little bit deformed. So, well, anyway, it was good for Paris. So what do we do for Marseille? Marseille is always a bit tricky, you know. You're far from the US, from Paris, so local rules maybe only are installed a little bit later than in the, say, the Anglo-Saxon world. But I was encouraged by the President of the Republic, who slightly over a week ago, he opened something, what's it called? Société Internationale de la Langue Française. Language issues in France, as we've seen, are something a bit complicated and tricky. And my speaking English is probably okay, but we should not really give in to too many things concerning, actually this was related to the écriture dite inclusive, which is also a hotly debated topic in France. I better not go into that right now. Anyway, things here are not as, what the word to use, let's say not as complicated as they are in the rest of the world. So finding an example in Marseille actually was not so complicated. I didn't have to ask the audience, you already find it yourself just by walking around in the supermarket. The local beer is called La Cagole. And of course, as a naive foreigner, you have no idea what La Cagole is supposed to mean. And actually, in the old days, there were your dictionary, right? Le Petit Robert. And there's 2 old copies you can take with you in the library these days because they don't want them anymore. They're on paper. 82, 92, there's no La Cagole. The word simply didn't exist in those days. And you can, of course, look at the bottle, what it is supposed to mean. Here we go. It's French, méfie. And it starts talking about beer, right? So, contrairement aux blondes fadas, la Cagole est brave caractère. So the beer has a nice character. It's not as bland as some other beers. And you like it, généreuse avec bien du parfum, t'as te régalé. So, looks like a good thing. And there is the French humorist, une collègue qui dit comment elle est bonne ta cagole, t'en gâte pas, il y a simplement bon goût. All right. That is maybe not as informative as you would like to have it as a foreigner. So you think, okay, the fridge magnets in Marseille look like this. You can just buy them. I did. Now I have one in Amsterdam on my fridge. It's a local thing. But what is La Cagole? Well, Of course, if I were to tell you, that'd be tricky, right? So in those days, you consult whatever dictionary. It is indeed something that didn't exist until relatively recently, local dialect. And so it's a young woman qui affiche une féminité provocante et vulgaire. Okay, sounds pretty negative. And it's also a stereotype. And apparently, Mia, the Native American lady, was also accused of being a stereotype, and that's enough to be cancelled. However, this being Marseille, being a stereotype, you can just be proud of your stereotype rather than cancel them, which seems to be the case in Marseille. So it's explained in some more detail in which way a cagole is different from other women, the way she looks, the way she behaves herself. And she also has, what I would call positive properties. Laisse pas marcher sur pied is good, I think, for a woman. And also it says in the end that apart from being in Marseille, by now it's everywhere in France in this century. So even though in the old days, and you can read where it comes from, that there are equivalent words in French that are plutôt péjoratif, which means not exactly very positive. And maybe I shouldn't pronounce all these P words. But le terme cagole a perdu au fil du temps qui le rendait insultant, which means that for a talk in Marseille at least, it's okay to use la cagole. So bear with me. There she is. And of course, you know what I can do to la cagole by now. I can do the standard zooming in, just like the nurse. And you get, indeed, it's a true Droste picture, and the corresponding Droste movie is completely periodic. There isn't much point in actually rotating the poor girl. Yeah, she might get dizzy, like you, and that's not too interesting. But you might, of course, Escherize her, and then she looks like this. And if you combine that with zooming in, you get an Escher picture with la cagole. And you can continue in various ways. Well, maybe I shouldn't play with the girl for too long. The only thing you need is the logarithmic plane having the cagole in infinite multiplicity, both in a vertical and a horizontal direction. And then you can do whatever you want. Here's the program. And yeah, you can, as I said, you can Escherize her one way or the other and combine it with zooming in or rotating and any speed and stare at the result. And it gives you exactly the Marseille equivalent of the Droste nurse. And yeah, what preference is you're Dutch, Marseille, or having been in Marseille. I don't know. Also, my time I think is sort of up. So actually, this is the situation for Escher. Here's the original Escher picture. And what we did is actually choosing a new 2 pi I vector, if you want. And that was the Escherized version of that picture. But there's a whole family of pictures of various kinds by doing that in different ways. So Escherizing can be done in many ways. So for la cagole, you can do it this way. This is a standard way. But you can also do the other way. That's 2 kinds already. Here is what happens if you square the poor girl. That means that you choose actually the 0, 2 point as your new 2 pi I. You can also use this in your course on complex analysis to explain what happens to the complex plane if you square. So you take the cube, that looks like this. And higher powers, they come like this. I think this is 0.07 in the plane. And some of them are pretty wild. Yeah, and it depends a bit on the speed, how dizzy you get, and how many cagole you can see at the same time. You focus on any point and try and discover how long it takes before you see it again. There's many examples. This is also a nice one, I think. And we've been playing quite a lot. You can do exactly the same thing for Escher already.
Thank you very much. Impressive. Are there any questions?
Mm-hmm. You get a microphone.
I was very interested by the aliasing you had in, because of course everything is pixelized anyway. Though if you go a little bit backward in La Cagole, when it was in kind of quite high.
What do you want to see?
Go back to La Cagole. But before, and at home stage here, this one, look at the aliasing which creates this spiral in the center. There is some aliasing, I'm quite sure it's, well, let's go. You see this spiral going on? You see that? Do you see what I see just at the center? It's because of pixelization. It's a kind of aliasing, I'm quite sure, it's my guess.
Yeah, exactly. And it also depends on the laptop you're using, the way it looks, right? Yeah.
So I like this phenomena, which is... to find it.
Yeah, there's lots of things to discover in La Cagole.
One, if you take an AI, because they read control.
Sorry, can you repeat? Oh, artificial intelligence.
I'm in Marseille, you would like across 5 drawings.
Well, you could, of course, try, but I'd be amazed. Of course, I'm so old that I think that AI cannot do this, but people are being surprised all the time, right? The link between, well, actually, by giving this talk and having it on the web, I guess it will help to associate art and Escher and La Cagole and Marseille. So pretty soon you may be able to do it and actually use La Cagole. Yeah. You had a different question. I think he's going to ask me, what is your memory of the semester?
Well, yes, it's generic.
And since I'm the last speaker, I actually could prepare the answer about my memory. And my most impressive memory, of course, is exactly the same as everybody else, so I needn't repeat it. But I turned 60 during this semester. And my birthday was organized by people like my co-chair Samuele, with all the Marseille people around him from the Cirm, of course. And it was a trip on a catamaran for 120 people during the main conference. Novembre, c'est plus... En tout cas, pour moi, c'était au mois de... In my case, it was in May. It was absolutely fantastic. So if you ever turn 60 and happen to be the Morlet Chair, go for it. Make sure you have the right co-chair. Samuele, thank you.